In 4.3, we're looking at geometric sequences in series. So last time we looked at arithmetic sequences, which is where you were adding or subtracting the same number every time. And for geometric, you're going to be multiplying or dividing by the same number every time. We usually just say multiplying, and if you're multiplying by a number less than 1, then actually you're dividing. So here in example 1, we're determining what kind of sequence it is, whether it's arithmetic, geometric, or neither. And then if it is arithmetic, find the common difference, and if it's geometric, find the common ratio. So for geometric, whatever you're multiplying by each time in the sequence, that is called the common ratio. We look in number A, and we see to get from one term to the next, we are multiplying by 3 every time. And so that is my common ratio, 3. To find that, if you have a hard time deciding what it is that you're multiplying by, you can always just take the second term divided by the first term, and that is how you get your common ratio. So here, if I divide these, I see that we are multiplying by 3/4 each time, but that is not working. That's not how you get each number. So we're not multiplying or dividing by the same thing every time, but what you do see is we are subtracting 9 each time. So if we're subtracting, then this is arithmetic, and the common difference is -9. So I should have said this is geometric, this is arithmetic. And then for C, it looks like we are multiplying each time by 1/2. And the negative is alternating, so we're multiplying by -1/2. -1/2, -1/2, -1/2. And so this is geometric, and my ratio is -1/2. We have a formula to find the nth term of a geometric sequence given here, just like we did in the arithmetic. And remember that R is your common ratio that we've been talking about. So we're going to use this formula in example 2. Find the next 3 terms of the geometric sequence. Actually, we're not using that formula yet. We're looking at the terms and figuring out what our R is. And it looks like here we are multiplying by 3 each time. And so if I take my starting sequence and keep multiplying by 3, the next number would be 81, then 243, and then 729. So those are the next 3 terms. Same thing for part B if you want to try it on your own. It looks like we are dividing by 2 or multiplying by 1/2 each time. So my R is 1/2. And if R is 1/2, then my next number would be 4, and then 2, and then 1 if we take half. So here we are using that formula. So our objective is we're finding the missing terms in the geometric sequence. Here we're looking for the 9th term. They've given me A1 and they've given me R. So they've given me everything we need to find the 9th term. So A1 is -3 times R is -2, and then n minus 1, since n is 9, it's 9 minus 1. So we have -3 times -2 to the 8th. So you're going to do -2 to the 8th first, exponents first, and then multiply by -3, and you should get -768. Part B, find the 12th term, knowing the first term and the ratio. So you can try it on your own if you want to pause. We'd have A12 equals A1 times common ratio 1/2 to the n minus 1, 12 minus 1. So you're going to do 1/2 to the 11th first, and then multiply that answer by 54, and you should get 3/100, or 0.03. In example 4, our objective is we are writing equations for geometric sequences. And then we're just stopping there. So it says write the equation of the nth term. Those are your directions that we had the other day too. but here we are just looking at a geometric one. So remember, the equation is a sub n equals a sub 1 times r to the n minus 1. So we have a sub 1. You can look and see what are you multiplying by each time. It looks like we're multiplying by 4, so we have an r of 4, and that's all you need is a1 and r. And so the nth term would be 3 times 4 to the n minus 1. And there is no way to simplify that any further, so you would just leave it as that. So equation for the nth term, you should have an equal sign, and you should have n's still in the equation for an equation of the nth term. Write an equation of the nth term for this geometric sequence. If you want to try it on your own, pause the video. If not, so we know a1 is 27. If we look, we're multiplying by a third each time, so that's r. And so my nth term would be 27 times 1/3 to the n minus 1. Next, we're looking at geometric series. So here's my equation for the sum of the first n terms of a series. Remember, a series is a sum. And in objective 3, we're looking to find the sum of a geometric series. So find the sum of the first 5 terms of a geometric series. I've got a1 is 4 and r. And so we plug that into our equation, and it said 5 terms, so that's n. So a1 is 4, 1 minus negative 1/2 to the nth, which is 5, over 1 minus negative 1/2. So I filled in all of my variables, and then I just want to go through and simplify and solve. So I've got 4 times 1, this negative 1/2 to the 5th is going to give, if you distribute your 5, is going to give you 1 over 32, and the negative will stay, but then you've got this double negative, which will change to plus. So we've got 1 plus 1 over 32. Here again, we've got double negative. 1 plus 1/2 is 3/2 if you get a common denominator. Again, in here, if you get a common denominator, if you get 32 over 32, this will become 33 over 32 when you add the fractions. And then you multiply by 4, and you're going to get 132 over 32, and then we multiply by the reciprocal of 3/2, which is 2/3, and you can reduce it down to 11/4. So I did a lot of this by hand. You don't have to. If you want to take it pretty far and type it into your calculator, you can, or you can type it in right away. If you do, you're looking to get 11/4 or 2.75, so just make sure you can type it in carefully to get that answer. B, if you want to try that on your own, go ahead and pause the video and try it. But my n is 8, a1 is 3, r is negative 2, so that is what we need. So we start with a1, then we have 1 minus our r to the nth, which is 8, over 1 minus r, which is negative 2. And so we're going to do negative 2 to the 8th first. The 8 is going to cancel that negative, and it's going to make it 256, but we still have that minus sign in front of it. And on the bottom, double negative changes to plus. The 3's cancel, and so I get 1 minus 256, which is negative 255. Again, I didn't need a calculator, but you could if you want to type it in right away. Here, same thing, only we are given it in sigma or summation notation. And so we're just going to pull out the information from this. So we're looking for the 6 terms added together. My first term, so since this is geometric, the rule is written as a sub 1 times r to the n minus 1. So my a sub 1 is 5. If we don't know that, what we can do is plug in 1 into the rule and we'll get 5. Or you can just look and see that it's 5. 1 minus r to the nth. Again, you can see the r is 2. And if you don't know, you could plug in numbers and see what they're going up by. So r to the nth, n is 6. It's always that number on top. And then we've got 1 minus r, which we already know is 2. And so if we solve all this, we should get 315. Here, same thing. If you want to try it on your own, we've got n is 4. A sub 1 is negative 4. 1 minus my r is 1/2 to the nth, which is 4, over 1 minus the r 1/2. So you pull your information from this notation and you put it into the equation that we've been using. You solve it step by step carefully, and you should end up getting negative 7.5. The last thing we're going to talk about is infinite geometric series. So this is our fourth objective. You'll be able to find the sum of infinite geometric series, and we have a different equation for this. It's infinite because we see the summation is going to infinity. It doesn't have an ending term. It just keeps on going. But the rule is we have to have r be less than 1, and this is the rule. So this is the setup. This is not the formula. What I just put a box around is the formula. And so this is what it will look like. This is the formula, and this is the restriction, that the ratio has to be less than 1. It can be negative, and it can be positive. That's what the absolute value means, but it has to be less than 1. So here they've given me everything I need. 5/8 is less than 1, so that works. So that means we can fill it in. My A1 is negative 7, and then 1 minus my common ratio 5/8. And so what we get is negative 7. If I get a common denominator, 8/8 minus 5/8 is 3/8. And then we take negative 7 times reciprocal. We end up getting negative 56/3. Or you can do it on a calculator. Here, 6/5. This is bigger than 1. 6/5 is larger than 1. So no sum. The sum does not exist. It's not going to equal one number. It's just going to get bigger and bigger and bigger and never equal one number. Here we need to find our common ratio. So it looks like we're multiplying by 5/4 each time. And that is larger than 1, so there's no sum. And then D, this is supposed to have an infinity on top. So if you can change that for me, please. It's not supposed to have a 10. We have A sub 1 is 50. We have R is 0.8. 0.8 luckily is less than 1, so there is a sum here. So we've got then A1 over 1 minus 0.8. So that's 50 divided by 0.2, which is 250.